Hello. Yes. We welcome you back to PSSB, Physical Sciences Silver Bullet. Today we are going to look at this number, this question. It comes from vertical projection. Okay, what does the statement say? It says a mobile phone is dropped from a helicopter which is vertically moving upwards with a constant velocity. At the time it's dropped, the helicopter is 48 meters above the ground. The phone takes 4 seconds to hit the ground. Now, what we are having here is the setup. This is the helicopter, and the height is 48 from the ground, and that's from where the mobile phone was dropped. Okay, now the question comes, calculate the velocity at which the helicopter is moving. How do we approach this question? This is what you have to know. That remember, the helicopter is vertically moving upwards at a constant velocity, and the stone is dropped. So we have to interpret that scenario. What happens under that circumstance? So what happens that when a mobile phone is dropped from the helicopter, which is vertically going upwards, the mobile phone is projected upwards with the velocity which is equal to the velocity of the helicopter. So initial velocity of the phone is that of the helicopter. So like we do all the projectiles, what do? We list the variables, the information we have. So from this situation, what are the information we are having? First of all, we don't know the velocity of the helicopter, which is supposed to be the velocity of the stone. So that one is wanted. But what do we know? We know that the helicopter is going upwards, so the mobile phone is projected upwards. So this makes our acceleration due to gravity to be negative 9.8 meters per second. What else do we know? We know the time, and this mobile phone takes 4 seconds to be projected, reaching maximum height and coming down to the ground. What else do we know? We know displacement, which is 48. But there's something we have to talk about displacement. To understand this, let us look at the trajectory. What happens here is that our mobile phone is projected upwards, reaches maximum height, comes down, passes point of projection, and lands on the ground. So what we have here, it is the trajectory, the path taken by the mobile phone. So when you look at this path, there's something we have to take note of. That if the projection is upwards, the displacement above the point of displacement is this one, and is positive. And the displacement below the point of displacement is negative. So from here, what is the conclusion? The conclusion is very simple. Our delta x, the height at which the stone is dropped, is below point of projection, because the phone initially goes upwards. So what does that mean? It means that our displacement is negative. So with this information, we can come up with the right formula. So what do we say? We're having the V, the G, the dt. What formula is this one? So for this one, the best formula is going to be this one. Some examination board calls it equation number 2. Some calls it number 3. But the equation is delta x equaling to VI delta t plus a half A delta t squared. So what do we have here? Well, all we have is the information which we are going to substitute. So this is negative 48, and our velocity is not known, but we know the time is 4. And what else do we know? We know the acceleration due to gravity, which is minus 9.8, and we know the time, which is 4. So from here, the only unknown is VI, which is calculatable. So let us press the calculator and see what we get. So this is what we get after computation. We get VI as 7.6 meters per second. So let's go to the next question, and please don't forget to subscribe. Yes, then comes this question. Let us look at the question. The question says that calculate the velocity at which the mobile phone hits the ground. So when you look at this question, what comes to your mind? Let us look at what we know. Okay, here, the best thing to know is to look at the trajectory. Our mobile phone initially was projected upwards by the virtue that the helicopter was going upwards, reaches maximum height, and come and hit the ground. This is the path which the stone took. And this path, the stone traveled that path, it took 4 seconds. Now, what else do we know about this? We know, because it is initially projected upwards, that acceleration due to gravity is negative 9.8 meters per second squared. What else do we know? We know there's something we need to know. Let us look at it here. Remember, this was the point of projection, so we know this height, which we call displacement, and we know its value. So the displacement is negative 4.8 meters, because it's below point of projection. Okay. Then what else do we know? Okay, let us bring in our unknown. We are calculating the final velocity. Okay. So with this information, how do you get final velocity? We might borrow the velocity we calculated, which the velocity of projection, which was 7.6 meters per second. So this is what we have. And what is the next phase is to look for the right equation. The equation which must have VI, it might have VF, it might have delta X. So when you look at the choice of the equation, the right choice of the equation, it can be equation number Number one, it can work. What does it say? Vf is equal to Vi plus A delta T. We can also use the second equation. So if you use this one, what is our Vf? It's wanted. What is Vi? It is 7.6. And what is A? It is negative 9.8. Then times the time of the flight, which is 4 seconds. And okay, if you look at this, the only unknown is Vf, which we just get by computation. So let us see what we get from here. So after substitution, we get our final velocity as 31.6 meters per second. Okay, so let us now go to the next question. Then comes this question 1.3. It says sketch the velocity time graph showing the initial velocity, the final velocity, the time to reach maximum height. So these are the things which we need to find. Okay, they want initial velocity. That one we have it. We calculated it. We have the final velocity. We did that one in 1.2. And we have this. Now, the time to reach maximum height, we do not have it. So what do we do? It's calculatable. Because if we recall that the initial velocity is 7.6 meters per second, and if we recall, remember we are talking about time to reach maximum height, so we know the final velocity, which is 0 meters per second. What else do we know? Projection is upwards, so we know G, which is negative 9.8 meters per second squared. Okay, then you bring in our unknown, which is delta T. So when you look at this data, the question is, what equation is this? So it can be the first equation. What does it say? Vf is equal to Vi plus A delta T, where Vf is 0. We're talking about maximum height here. Where Vi is 7.6. Acceleration is negative 9.8 delta T. Now when you look at this equation, the only unknown is delta T, which is calculatable. So let us find out what it is. So this is what we get after substitution. We get that the time to reach maximum height is 0.78. So it's like now we have all the information to draw our graph. Let us see what we can do. So on assumption that this is the sketch we are having, so let us look at what we have. If this is our velocity in meters per second, and on this axis we'll have the time. Okay, then what do we have to do? We have to remember that the mobile phone was initially projected upwards. So this is what we are having. We are having the mobile phone moving upwards until it reaches maximum height. Then after reaching maximum height, it changes direction, coming down until it hits the ground. So what we have here is the sketch of the velocity time graph of the mobile phone. This one indicates the initial velocity, which is 7.6. What we have here indicates the time to reach maximum height, which you found as 0.78. What we have here is the velocity at which the mobile phone hits the ground. We did that one. I think it was 31.6. And what we have here is the time the mobile phone took from point of projection to the ground, and that one is given in the statement. It is 4 seconds. You have to remember that this time is in seconds. So this is generally what we have as the sketch. Don't forget to subscribe. Let us look at the next question. Yeah, then comes this question, question 1.4. It reads, sketch position time graph indicating maximum height, the initial height, time to reach maximum height, and time to reach the ground. So that's what we have. Now, when you look at, this is the information they want us to indicate. One is maximum height. And guess what? We do not have that. We have not calculated that one anywhere. So that's that. Let us indicate others. What else do we see here? There is initial height. That one we know. It's in the statement. And time to reach maximum height. That one we calculated it. Time to reach the ground. That one is in the statement. So generally, this is what we are supposed to indicate. So what is pending is the maximum height and is calculatable. If we recall, we have VI as 7.6 meters per second going upwards. So that one brings in our G, which is negative 9.8 meters per second squared. What else do we know? We are talking about maximum height. So we know the final velocity, which is 0 meters per second. And then you bring in our unknown. So when you look at this data, which equation is this one? The best equation here is going to be equation number 2. It says VF squared is equal to VI squared plus 2A delta X. So when you come to substitute, you have 0 is equal to 7.6 squared plus 2 times negative 9.8 delta X. Delta X being our maximum height. When you look at the equation, this is the only unknown, and we can easily find it out. Let us see what we can do to get it. So after substitution, this is what we get. We get our maximum height as 2.95 meters. So it's like now we have all the information which is required and to sketch position time graph. Let us see what we can do here. So on assumption that what we have here are the axes, so what do we know? We know that this one is going to be our position. In meters, and this one is going to be our time in seconds. Okay, then what else do we know? This, we know that the mobile phone was initially projected upwards, so this is what we know. It rose up, reached maximum height, then it came and hit the ground. So that's what we have. Okay, so if this is what we have, what are the values which comes with this diagram? You have to remember that here they said we are going to use point of projection as the reference. Reference means what you are going to call your zero. So this is our zero, and you remember, according to Cartesian planes, the numbers above the origin are positive and those ones below are negative. So what we have here, we have a figure here which indicates maximum height, and our maximum height, it was calculated as 2.95. It's positive, and we know the time to reach maximum height. And what was it? We found it as can come here as 0.78 seconds. What else do we know? We know the time for the entire flight, and that time was given the statement as 4 seconds. What else do we know? We know the height from which projection took place, and that height was 48. But you have to know that we are using this one as 0 as our reference. So any displacement below or any distance covered below is going to be negative. So here we are having our negative 48 meters. This is when you are using the ground, when you are using the point of projection as a reference. At times they might tell you to use the ground as a reference. So when you use the ground as a reference, this one becomes 0, and all these values are going to be additive. So this one will be 48, this one will be 48 plus 2.95. Okay, with that, the question has ended, and we appreciate your time. Let us look at other questions which are associated with this one, with this sketch. Okay, and then comes this question. It reads, the car is 20 meters away. At the instant the mobile phone is dropped. The car is moving towards X, I mean at this point here, at constant velocity. The car's height is given, it's 2.3 meters, and it is hit by the stone. Then they say calculate the speed of the car. So when you look at this scenario, you're talking about the car. And what do we know about the car? We know that it's moving with a constant velocity, which is not known. And what is doing about the car? We know that it is going to cover 20 meters before it is hit by the mobile phone, because it was 20 meters at the instant the mobile phone was dropped. So if it was hit by the stone, the implication is that it covered 20 meters to be hit by the stone. Then what we have here, the concept of time is the problem. We don't have time, we don't have velocity, but this is what we know. We know that if we apply the third equation, okay, if we apply the third equation, which is delta x equals to vi delta t plus a half a delta t squared. This is what we have to remember. You have to remember that the car is moving at constant velocity. Constant velocity implies that our acceleration is 0. Acceleration 0 implies that all this one is going to become 0. So what equation do we have? We have equation which is delta x equals to vi delta t. Okay. Now when you look at that equation, what do you see? You see that you have displacement, which the car is going to cover, which is 20 meters. And this is our unknown. The speed of the car is what we are going to calculate. So what does that mean? It means that we must have delta t. And delta t is calculatable, as we are going to see. So to calculate delta t, there is some information we need to know. Okay, when you go back to the trajectory that the mobile phone was projected upwards and it took this path. Now we know the velocity of projection, which is 7.6 meters. But there's something you need to know. We have the car here, and the car's height is 2.3 meters. Now, if that height is 2.3 meters, and we know that this entire height from here to the ground is 48 meters, then it means that we know this height, which the mobile phone traveled to strike the car. It's going to be 48 minus 2.3. What you get there is going to be our height. So we have the height. So this is the displacement the mobile phone is supposed to cover to strike the top of the car. So when you go by that, then it means that we have the information. What is it? We know displacement. It is negative 45.7 meters. Remember, it is below point of projection. We know VI is 7 9.6 meters per second. Okay. What else do we know? The ball is projected upwards, so we know G as negative 9.8 meters per second squared. And what are we calculating here? We are calculating the time of the flight. That time is what we need to calculate the velocity of the car. So with this information, you have to think about the equation. What is the appropriate equation for this one? It's going to be the third one, which is delta x is equal to vi delta t plus a half a delta t squared. When you substitute, you have 45.7 and you have 7.6 here, delta t plus a half times negative 9.8 delta t. Now when you look at this one takes you to quadratic to get our delta t, which we can do. So let us see what we can do here. So after computation, this is what we get. We get our time as 3.93 seconds. So what do you do with this time? You go ahead and substitute in the equation of the car. This is the time the car took to travel that distance of 20 meters to be hit by the stone. So let us look at it. So after substitution, we get our velocity as 5.09. So this is the velocity at which the car was moving. Remember, it was constant. Then we look at the last part of this setup and we close the question. Okay. Then comes this question. It says that Bongane is 10 meters away from point X. At the instant the mobile phone is dropped, moving at 2.5 meters per second towards point X. So the question says, will Bongane catch the phone? Use calculations to show how you arrived at your answer. So when you look at this one, let us look at Bongane. Bongane is moving at constant velocity, which is 2.5 meters per second. And we know Bongane's displacement is 10 meters away. From this information, we can think of the time. So which equation fits this one? Remember, we are talking about Bongane moving on the ground, so we are going to bring in G. So what are you going to say? We are going to say, if we apply this equation, which is delta x equal to vi delta t plus a half a delta t squared, you have to remember that because Bongane is moving with uniform velocity, this one is 0. So when acceleration is 0, it means that this entire part is 0. What does that mean? We have now delta x equals to vi delta t. When you look at this information, what do we know? We know this one, our displacement. We know the velocity, which is 2.5. And we are calculating delta t. Okay, so from here we know delta t, which is going to be equal to delta c. So after substitution, we have the time as 4 seconds. So Bongani took 4 seconds to reach point X. Now the question still stands. Will Bongani catch the phone? So here you have to go and check for our time of flight of the mobile phone. It is 4 seconds and Bongani used 4 seconds. So the answer is yes. Yes, Bongani will catch what? The phone. Why? Because the time is the same. If Bongani traveled for a longer time to reach point X, he can't catch the phone. So answer is yes. Thanks very much. We appreciate your time. Don't forget to subscribe. The channel is PSSB and it's me, Richard. Yeah, see you next time. Bye bye.